Hello everyone. In this video, we are going to study about phase equilibria. There are some topics which we will cover in this video. The introduction to phase equilibria, the stability of a pure substance, the Clapeyron equation, equilibrium between various phases such as solid, liquid gas, etc., and the phase diagram and its importance. The Gibbs free energy dG is given by minus entropy into dt plus volume into dP. Consider this as equation number 1. Divide equation number 1 with number of moles n. The first quantity, which is Gibbs free energy per mole, is called the chemical potential of that substance, denoted as dν, which is equal to molar entropy into dt plus molar volume into dP. Consider this as equation number 2. At constant pressure, dP is equal to 0, hence dν is equal to minus molar entropy into dt. Hence, dν by dt is equal to molar entropy. If we plot a graph of chemical potential versus temperature for the three phases, that is gas, liquid and solid, we will get three curves having different slopes. We know that the entropy of gas is more than entropy of liquid, which is more than the entropy of solid at any temperature. We plotted three curves of the respective three phases, that is solid, liquid and gas. As we all know, at any temperature, the phase with the least chemical potential is the most stable phase. The temperature axis is divided into three regions, that is 0 to Tm, Tm to Tb and Tb to infinity. We can see that from 0 to Tm, the solid phase has the least chemical potential and is the most stable phase. From Tm to Tb, the liquid phase has the least chemical potential and is the most stable phase. Above Tb, the gaseous phase has the least chemical potential and thus gaseous phase is most stable at any temperature beyond Tb. We can conclude that Tm is the melting point of that substance and Tb is the boiling point of that substance. For two phases alpha and beta to be in equilibrium, the condition is that the chemical potential of the phase alpha should be equal to the chemical potential of the phase beta at temperature T. In the above graph, there are two temperatures at which two phases exist in equilibrium. The temperature Tm, where the solid and the liquid phase exist in equilibrium, and the temperature Tb, where the liquid and the gaseous phase exist in equilibrium at temperature Tb. Now we will study about the Clapeyron equation, which deals with the condition when the two phases alpha and beta are in equilibrium. We all know that when alpha and beta are in equilibrium, the chemical potential of the two phases are equal. The Clapeyron equation states that dt by dP is equal to del volume by del entropy. This is the condition for equilibrium and is also known as the Clapeyron equation. We will study about the various equilibrium, that is solid liquid equilibrium, the liquid gas equilibrium and the gas solid equilibrium, and analyze it graphically using the Clapeyron equation. So let's start. First, the solid liquid equilibrium. We all know the Clapeyron equation states that dt by dp is equal to del v by del s. For the transition from solid to liquid, we all know that del s is always a positive quantity. As far as del v is concerned, del v is positive for most of the substance except water. For water, del v is negative. We will see that later. When we plot a graph between temperature and pressure, it shows as follows. So here is the graph. This line shows the various conditions of temperature and pressure at which the solid and liquid phase coexist in equilibrium of a particular substance. I repeat, this curve shows the various conditions of temperature and pressure at which solid phase and liquid phase of a substance coexist in equilibrium. Now we will study about the liquid gas equilibrium. For liquid gas equilibrium, the entropy del S is always a positive quantity and the volume is also a positive quantity. Hence, when we plot a graph of temperature and pressure, it shows as follows. As we all know, this line shows the equilibrium between solid phase and liquid phase. This line shows the equilibrium condition between liquid phase and gaseous phase. This point is known as the triple point. The definition of the triple point: it is a point at which the three phases, that is solid, liquid and gas, coexist at equilibrium. Hence, mu of solid is equal to mu of liquid is equal to mu of gas at the triple point. Now we will study about phase diagram. What is a phase diagram? It is a graph between pressure and temperature which shows the various equilibrium condition between the various phases of a substance at different condition of temperature and pressure. In this case, we will talk about carbon dioxide and its various condition for equilibrium between its various phases, that is solid, liquid and gas. Why phase diagram has such a vast importance? Because phase diagram can be helpful to find out the melting point of that substance, the boiling point of that substance, the transition point, the triple point and also the critical point of that substance. We can see that when the pressure is 1 atm, the graph cuts the line OB with temperature minus 78.5 degrees Celsius. This is known as the transition point. When at this temperature the solid carbon dioxide gets converted into the gaseous carbon dioxide. The triple point of carbon dioxide is 5.1 atm at minus 56.7 degrees Celsius. The critical point beyond which gaseous carbon dioxide can't be liquefied no matter how much pressure we apply. That is at 31 degrees Celsius and at 72.9 atm. This is the phase diagram of water. As we can see that the equilibrium line of ice and water has a negative slope. This is due to the fact that from transition from solid to liquid, the del V is negative. Hence the slope, that is dP by dt, is also a negative quantity. So as we can see that at 1 atm the melting point is 0 degrees Celsius and the boiling point is 100 degrees Celsius. The critical point of water is at 218 atm and 374 degrees Celsius. The triple point of water, that is when ice, water and water vapor coexist in equilibrium, is at 0.006 atm and at 0.01 degrees Celsius. That's all for the phase diagram of water. For notes of these topics, kindly leave a comment below and I'll reply to all of them. Thank you for watching this video. Do like, do subscribe for more chemistry related content. Thank you.